And now Renaud Bidou on JavaScript, malware, botnets. You have the floor.
Thank you. Morning, everybody. So I'm Renaud, and I'm going to talk about something which is very simple, actually deadly simple, and that's the problem, and that's the reason I'm here. So just a quick introduction to, about JavaScript. The first thing is, well, what about JavaScript today? So it's wrong just to talk about JavaScript. JavaScript comes from ECMAScript, and ECMAScript is a language that you will find like almost everywhere. So of course, we've got the core that you will find in your browsers, you've got the V8, and you've got everything that can be found in Adobe products. You will find it in .NET. So actually, when you've got something running JavaScript, it can run like almost everywhere, not only into the browser, but into, well, plugins, into on the system itself. So it shows that it's pretty powerful. So why do you want JavaScript in botnet? Well, actually, when you want to create a botnet, you require some kind, for injection first. So there are many ways offered by JavaScript or ECMAScript or whatever to do that. You need C2, and you've got solutions for that with JavaScript. You need persistency and agility, and you will see that we can do that also. Of course, you have to propagate, you have to evade detection that you can find in the networks. You can still do that. And last but not least, of course, you need to do something, because it's cool to propagate and to infect, but you need to do something. And now with JavaScript or ECMAScript or whatever script, you can do many, many things which are very useful and that you will find in current botnets. So why? Well, just because everything you need, you will find it into JavaScript. So first, let's talk about the injection, the 101. So of course, I guess most of you heard about cross-site scripting. It's often considered as the buffer overflow of the decade because it's very easy to write. It can, well, it propagates through vulnerable websites, so everywhere. It's marvelous, the vector. So just remember, it's a second-order attack. The real target is the browser, and it's going to use some vulnerable web servers just like relays. So the attacker is going to just exploit a vulnerability in the server, put something in, so that's for the persistent cross-site scripting. A user is going to connect, get the page, and gets the malware from the page, completely embedded. You see nothing, and it runs on the browser itself. So, well, okay, that's very basic. Well, there are some unexpected vectors. So, well, just what I said is that JavaScript hasn't to be just considered as something running into your browser. It can run onto your system, and any kind of usual spam and malware that you will find in mails can be written in JavaScript. Well, the latest downloader for Cryptable 4 is just GScript, and GScript, you can just click it. It's going to be executed with Windows scripting host. You can embed it into a Word document and have somebody click on something. So it's pretty easy. Usually, you just put a red button and say, don't click on the button. People are going to click on it. So, well, usual social engineering works very well. So, but there are even more unexpected vectors. So, well, as I said, you can just execute GScript directly from the command line on Windows, so different versions depending on the framework you've got. Also, well, I just talk about some variants. You know that cross-site scripting is often quite difficult to execute because you've got some protections on the browsers. One of them is the same origin policy. So there are some ways, just to evade that. So that's a pretty recent one, quite smart. What we're doing is that we're using some callback functions. So you see it works in JavaScript or Flash. As I said, it's very portable. And here we're just going to override the callback function using some embedded function that we will find into the page. And that's pretty interesting because also we're using actually the parent window. So we're not calling some script somewhere else. We're just using the code itself. And we'll see with some other interesting stuff, just like the cross-site scripting injection. There are some ways just to call, get back some JavaScript, have it executed just this way. So completely transparent. No browser security is going to be able to protect that. And very recently, there's been a proof of concept, which is quite interesting, because, well, we managed to have some cross-site scripting through FTP. So that's cool. Well, depends which side you're on. But let's say that it opens differently new vectors. And so, just saying, OK, I don't use browser, I use no script or whatever. OK, it's not enough. You can be infected in different ways. So the very well-known problem with cross-site scripting or this kind of stuff is persistency. So here there are different ways to maintain persistency and make sure that your, let's say, your script is going to be executed anyway, even if you change the page, even if whatever. So that's just a small example of browser compromise. So we're going just to, well, let's say, write a small Chrome extension that is going to be launched each time while you run Chrome. So how to do that? So first you need, well, a loader, which means that this small piece of code is like going to be run in the background. Every 10 seconds, going to call itself, call the function. Function creates a script tag into the header, and this script tag is going to get its code from somewhere. Okay, so, well, usually the C2. So it means that every 10 seconds it's going to renew itself and launch any new code you want. So we get some kind of flexibility. That's, well, very common, you know. You need the manifest for your Chrome extension. So name version, the icon is just for proof of concept, of course. You should not use it. And then what it does here, it's pretty simple. It's going to execute our loader each time you connect to a web page. So, well, it means each time you launch, you fire Chrome, well, it's going to execute the loader, and then you've got everything running. So the icon for the proof of concept directory, we're going to extract those files, and the command execution. So here, what we just have to do is launch Chrome with these arguments, and then, well, it just means that you have to replace all the links or shortcuts for Chrome, and then it works. Then you launch Chrome, and you see you've got the small stuff here. And this can be done entirely in JavaScript. So if you use the XML HTTP for, well, to download, you know, the files, you're going to use the WScript shell, just, you know, to browse, to create directories, to find the shortcuts, to find Chrome, to rewrite all this. And you say all this is text, so I say you use HTML HTTP object to download, but you don't really need it. This can be done, you know, just like a dropper. It's text, so just copy it and it works. This is pretty simple, everything that you will find on any Windows machine. Also, we need to, you know, be able to transfer data quite transparent. I mean, not, well, you will see what I mean. So that's art? No, that's JavaScript. So how do we do that? Very simple. So what we're going to do is simply generate a PNG file based on our JavaScript. So, well, if you use index color, you will still see the code. But if you use true colors, it's not even. So that's where it's interesting. When you can have IDS, IPS, whatever, it's somewhere hidden. So of course, if you decrypt it, well, not decrypt, decode it, you will find it. But you know, it takes a lot of processing, a lot of time. Not sure anybody's going to spend time. So, well, once again, the image itself doesn't do much. But you can write this, once again. Once you inject it, you run whatever you want, and it looks like, you know, quite innocuous, just like loading an image. And that's what we're doing. We get the image, so we do, well, just looking for image SRC, so no SOAP. CSP is usually not defined for images, so no problem, will not get blocked. You load, you decode, and you execute through the eval function that we've got in JavaScript. So very simple. Of course, cleanup, so it will not be even, well, visible in the DOM if you just have to want to have a look. And then, of course, it works. It was a pretty simple one. Well, now we know that for botnets, sinews of war are the C2. We kill the C2, no more botnet. So how can we have a botnet? Well, a C2 that's quite resistant. Let's say you don't even want, you know, firewalls or whatever to block the communication to the botnet. So, well, very simple, use Twitter, because, well, people are not going to block Twitter connections. So once again, very simple piece of code. So here, well, I tweet with my username, that's botnet master. You've got a hashtag with the command. Now, the JavaScript which is running here, it's just going to look for these specific elements. Okay, and every 10 seconds, I think in the example, it's going to do a request. Just get the info, parse the response, and here, well, of course, you've got your command here. So the command can be, well, embedded command, I mean, hard-coded. It can be raw JavaScript, it can be an image. Just an image URL, you're going to get the image, and we're back to what we just discussed a few minutes ago. Okay, so now the magic of JavaScript. Years ago, anything you can do with JavaScript was usually stealing cookies. Okay, that's cool, but it's been some time now. Thanks to, well, the Web 2 and whatever we call it, there are a lot of new features which are available. So together, JavaScript, HTML5. So, well, first in terms of capture, we've got keyloggers. So here I'm just going to give some examples. There are many, many ways to do things. Some have some restrictions, whatever we can discuss later on, but let's say that usually this works. So a keylogger, what we want here is to be able to track even a session. So the guy is going to connect, type something in a text field, then in another, then come back, etc. You want to see everything. So you're creating just an invisible iframe, so that's one of the implementation, something somewhere nobody sees. And each time a guy is going to press a key, you're going to write like a new URL with a new query string. The query string is going to embed the key that you just struck the field and a session ID. I wanted it to be session persistent. And we're going just, to like say that the source of the iframe is this URL we just built. And here we can see that all the requests which are done into Chrome just to, well, to provide information. So on the other side, what you've got this. That's pretty simple. Okay, so you've got the IP address, you've got a session number, you've got the field and the values. So it's not new. You can play with the browser. That's much more funny. You can do screenshots. So there's a tool it's called HTML to Canvas, which is going to convert all the HTML stuff into an image, and then build the image and send it somewhere. Works very well. Very recent one, a tool called Sniffly, I think it's the way you pronounce it, which is going to abuse HSTS and CSP. So here what we want to know if a user has browsed on some websites. So there are some restrictions, but anyway, what you do, you're connecting there to a malicious website. So you get, you get back a page with some restriction. One of them says, okay, for image, I'll allow only HTTP. And then I say connect to this website. That's the website I want to know if he connected to before. This site has to be HSTS, so the request is going to be HTTPS. So CSP is going to be violated, it's going to be blocked, and then we'll see how the image is going to be loaded. If it's in the cache, it's going to be very fast. So we know it went from this site already. And if it's not the case, it takes longer, we know it doesn't. So that's more or less a proof of concept, but very interesting. Different ways also to steal what you can find into forms. So, well, not necessary to go over them, but let's say that it's just playing with the DOM. So you can overload functions, you can divert action fields, etc. Anyway, whatever the guy does, the one on the bottom left is pretty interesting because we also play with the autocomplete. So, just the guy starts something and you see everything which is in. So that's cool one. Well, we're also interested into users. Okay, it's cool to steal the data or to capture. So a funny one, of course, it's, well, just, exploiting HTML5 just to get some snapshot from the webcam. So it's more or less the same idea. You create a canvas stuff, you get the stream from the video, convert it into an image, put it into a canvas export, and you got a picture for that. So there are some restrictions, I know, but if you use a website that already used the webcam, so we already approved for that, a funny trick that seems to work also is to have some kind of link. So the guy wants to click on it, and the first time it does nothing. So it's going to click another time, and just the time where the pop-up says they want to use the webcam. So it's been proved that it works pretty well with the usual users that clicks on anything anyway. Actions, interesting. Being able to see all the events into a window. So here what we are doing, we are just, hiding the original page, create a full frame, a full page iframe, and load the page into it. So it means that you manage completely the page. So you can create hooks for any event which is created, which is intercepted, and this is what I do. Also some ways to alter the clipboard. So a POC for that has been demonstrated, pretty efficient. So actually you see what's selected, and you just change that. So the guy wants to do a copy and paste, and it's pasting something that was not supposed to paste. You can steal the HTML5 local storage, very simple. You test to see if it works. Then And last one, which is very interesting, it's cross-site scripting injection. So here, what happens is that you're going to load some JavaScript stuff from another site, just like Facebook or Twitter. And then when you load this, you get some global variables that you can access from your script because he loaded the second one. So, and there are many, many things which are interesting. It's cookies, of course. Well, that's UIDs, personal data. And you can say, well, are you sure? Yeah, I am, because, well, I didn't do the test, but the kitten pigs guy did it. And over 150 major websites, there's a lot of vulnerabilities, even on Facebook. Here you can see they stole interesting information, age of the guy, number of friends, etc., etc. So all this was somewhere into JavaScript, which was stolen. So we can do many things. And now we need to propagate. So first we need to get some system info. We can get a lot of browser details. That's basic. I mean, it's been there for ages, so, well, let's say nobody cares. Well, nobody cares. It's not rocket science, but here you see all the versions of all the plugins, so that's also a great help for exploits. You can get the local IPs. That's pretty new also. I mean, 1 year, a few months old. So you're using the WebRTC protocol, so you connect to S3 server. That's usually makes it possible to a computer to connect together through NAT. And then it means you're going to have what they call ICE candidates. In the ICE candidates, you've got all the IP addresses, public and private. So it means that we've got the private IP address of the machine. And then we can start scanning. So the old techniques use images. Okay, that's interesting. There's no same origin policy. So that's pretty long. You have to tune the timeouts, etc. So not very reliable. Another one, of course, is just the XHR, but here you've got the SOAP issue. Well, hopefully we've got a new one with the WebSockets, so thanks to HTML5. So here, no SOAP, it's fast, it's reliable. So it's more than port scan, you can even do network scan. So, well, let's see all together. We've got all the system information, we've got local network, we've got capability to scan. So now we can start to massively get into stuff. And that's Sonar, so a pretty new software also, that collects local IPs. It's going to fingerprint the stuff. It's going to scan, of course, first, fingerprint, find vulnerabilities, and compromise. So 2 types of compromise are interesting. First one are routers. Why? Because we know that Soho routers have the same login password accessible from the internal network, etc., etc. So we can change anything for, the man in the middle or, whatever you want. And, of course, vulnerable web applications. So it means that, we can find vulnerable web applications and, have a stored cross-site scripting there. So it's propagating into the internal network. So it means, a lot of interesting things. First, of course, no firewall, no security usually. And also it's the internal network. It means that your browser security is set to low because, you trust it's your network. So, everything that can be run, then active objects, etc., etc. Also, you don't want to get code. So you need your explode code to explode the XSS to change. So we need some stealth stuff. So, that's where we can use polymorphic code. So, polymorph code, it's just like we know that for years, but you can do that in JavaScript also. That's what's cool. So here, what you've got this piece of code which is going to propagate itself and encode it. Okay, I don't even talk about encryption, it's just encoding. So, each time the packet is going to be rebuilt, or the payload is going to be rebuilt, so you define an IV. With this IV, you're going to encode. Okay, and then just have to define the decoding routing and execution. Now, an execution is going to decode itself, find itself first in the page, decode itself, re-encode. And then once it's re-encoded, it's going there, and you see that we're executing, propagating, and we're back to the beginning. And this is what it looks like. So once again, it's a proof of concept. Why? Because we've got a lot of static stuff, just like warm start. Of course, we will not use that. Too easy to catch, but that's very easy to randomize this stuff. So we'll just see how it works. We've got the packet code, so this code is going to change each and every time you're going to propagate to a new host. You've got the IV here there, and we can see decoding and execution routines. So as a conclusion, all you need is JavaScript. That's, let's say, the global stuff. So now, we've got, from one way to another, we don't really care, this malware getting to the computer. So click on something, download something, cross-site scripting, as usual. We've got persistency, we saw that. We connect to the command and control network, which shall not be down for quite a time because downing Twitter is not that easy. You get back an image. Okay, I downloaded an image, not necessarily very violent, let's say. Then from there, we saw several operations, scanning, fingerprinting, and then intrusion into a server. So that's interesting because this server can be internal, so everybody in the internet network will get caught. But also, it can be, like a public web server. So everybody who is going to connect there, from anywhere is going to be also to be in the loop. And then we're back to the first point. So this is a 100% JavaScript-based botnet. So I think that's a threat that will come very soon because all this can be seen like more or less legitimate. And, well, actually, it's not. So a lot of credits because actually I did nothing by myself. I just compiled everything from what I found on different places. So you see, all this exists. It's not only imagination. All this code is already available somewhere. So thank you very much. You got any question?
Question time. Oh. Là-bas, là-bas. Là-bas d'abord.
Hello.
Hello.
First, nice lecture, by the way. And
Thanks.
first question, if can you put again the credit slide so we can copy it?
Yeah, no problem.
And the next question is, what is the common vector of causing the user to install the Chrome extension?
Well, actually, he's not going to see anything. Well, let's say the easiest one will be just JavaScript, which is executed. So it can be into, you can embed it into a Word document. When you click on it, so embedded object, it's going to be executed, so it's GScript. It's going to be executed by the Windows scripting host.
And this script will install the extension?
Yeah, automatically. So,
Okay.
and then, well, any other kind of vector, you will have to trick the user. Usually, I didn't manage to have it done automatically. I didn't talk about it, but first download can be done on Chrome, by the way. So pretty simple, but you still need the guy to click on something. But, we're talking about botnets, so it's high volume. If for targeted attack, it's going to be more difficult. But for botnets, you're sending out 1 million email, you still have like 1% of the guys which are going to click on it. Especially, as I said, if you said don't click on it.
Yeah. Thank you.
You're welcome.
Hi, Zoltán. As far as I know, Chrome enforces the Chrome extension store for extensions. And if you want to install a new extension, which is not on the extension store, first you have to switch to developer mode.
Not necessarily, because here it means that you download the package extension. But as I showed, what you're just doing is just you're creating a directory, and then you load Chrome with the load extension arguments that points to the directory. It's going to be loaded. So it's not the package one that you're downloading from whatever, and then it works.
Question here. All that stuff is separated research. Renaud?
Oh, hey.
So all that stuff is actually separated research, but
Yeah.
have you seen all that stuff used together in the wild?
No, not yet, hopefully. But purpose is to prepare what's coming on. I think it's going to be soon.
Hi, so I'm Mark, I'm at Facebook. We've been battling Chrome extensions and Firefox extensions for about 3.5 years. I can walk through like the painful history of why it is incredibly simple to build a botnet using these things. To answer the earlier question about the installs, yes, it's largely just go to a website, you embed a meta tag in the page that basically generates a pop-up in Chrome like install this extension, allow, deny, they click allow, they're done. So yeah, thank you for giving the talk. Glad to see that somebody else notices the same problem, that you can build a botnet in 15 seconds and push it through the Chrome store.
Another question? Everybody on this side is sleeping, or? Yeah.
For the case of Twitter, do you have any idea, or do you know if they are planning to do some countermeasures to prevent it to be used as CNC, or
That's
is it just a proof of concept for now, or has
Yeah.
already been used for
It's,
real?
well, it's proof of concept, but well, we disappeared again. But it's been done by a guy who just published this, so I had to fix a few things, but it works pretty well. And now the problem is, of course, I mean, just like for any botnet, if you know the command, let's say the command language, or you know the syntax, you can block some keywords. But you know, here we see that every 10 seconds, or even less if we want, we can renew and download new version. So I can just change, you know, the hashtag like every 10 seconds, so you cannot block it. So, and then the user, you can create new users, etc. So it's possible, but it's very difficult because you have to be fast. And even if you update like signatures or behavioral, I don't know. So I don't think that's going to be a solution for this kind of stuff. But maybe seeing that it's a script connecting to Chrome, getting images, I don't know. We're still working on that.
Thank you.
Okay. Okay. Thank you.
Thank you very much.